Hi everyone, today we're going to look into a list of separation techniques that are must-knows for the IB chemistry syllabus. And this is part of the first chapter of the IB chemistry syllabus, and a couple of techniques that we need to know are filtration, evaporation, distillation, chromatography, recrystallization, and thin layer chromatography and two-dimensional chromatography, both of which are not exactly on the syllabus, but they are must-knows in order to fully understand the properties and functions of paper chromatography. So let's get started. First, let's start off with filtration. Now, filtration is essentially the process to separate an insoluble solid from a liquid, and it does so by passing the mixture through a porous medium. The sort of equipment that we need for this process is filter funnel. We also need a filter paper, beaker. And the step for this is we firstly place the filter paper in the funnel, and we pour the heterogeneous mixture. Now, some of you might have heard the word heterogeneous, but you may not exactly know what it means. A heterogeneous mixture compared to a homogeneous mixture is one that has usually a non-uniform composition, and we can visibly see that there are more than one component involved. And sometimes a heterogeneous mixtures usually have like different states, various states in one mixture. After pouring the heterogeneous mixture, we will be collecting what is a residue, which is essentially a solid that's trapped in paper, in the filter paper that we discussed above, and we're going to collect to filter it. And this is essentially just the liquid that's collected below, usually in a conical flask. Next, let's move on to evaporation. Evaporation is essentially a technique used in order to recover a dissolved solute from a solution by removing the solvent through heating. And what this essentially involves is we first heat the solution until the solvent evaporates, and we're essentially going to get the solid solute. The underlying principle behind this is solvent volatility, and if you don't know what I mean by that, it's essentially stating that boiling point must be lower than the decomposition point of the solute. Next technique that we're going to observe is distillation, and it essentially refers to separating miscible liquids. Miscible means like liquids that can dissolve in each other based on different boiling points, and this divides into fractional and just simple distillation depending on like how the difference between the boiling points are. If the difference is fast, we usually use simple distillation. If the difference is narrow, we use fractional distillation. This is just like a couple of side notes that I took. I wanted to know the difference between vaporization and evaporation, and apparently vaporization is just the act of becoming gas. Solid to gas is also vaporization, although we just usually term it as sublimation. Liquid to gas is also a case of vaporization, but evaporation specifically refers to liquid becoming gas at the surface of the liquid, and also it occurs at below boiling point. A couple of other things that we really need to know is that the difference between evaporation and boiling is that the vaporization pressure is smaller than the atmospheric pressure in evaporation, and boiling point refers to this essentially. Now let's look at chromatography. Chromatography is essentially separating mixture components based on differences in affinity between the mobile phase and the stationary phase. So the mobile phase would always be the sort of solvent, and the stationary phase would be the paper. So any sorts of mixtures or any sort of dyes usually used in chromatography, if they have greater affinity to the mobile phase, which is the solvent, they're going to move up the chromatography paper. If they have greater affinity to the stationary phase, which is the paper, it generally means that they have less solubility in the solvent, so they'll move less. The next technique to look into is recrystallization, and it's essentially the purification of a solid by exploiting the temperature-dependent soluble differences. And although I kind of phrased it a little bit difficultly, it's just referring to the act of having to create a solid essentially using the properties of the melting point and the differences in the melting point of different like dissolved solutes, and essentially using that to create solids. However, these solids will be formed in different like temperatures because the melting point of different substances that are dissolved in the mixture will be different. So the way that we do this is we dissolve an impure solid in a minimal hot solvent, and we filter it in order to remove the insoluble impurities. Then we're going to cool slowly, so pure crystals we're going to form, and then we're going to filter and collect the crystals, and we're going to dry the product. This is pretty much just how it goes. Next, we're going to look into thin layer chromatography, and again, this is kind of like an extension of the chromatography that we just talked about. We kind of use the same principles. Mobile phase, we still have the solvent. Stationary phase, we're going to have the silica plate and the paper. I guess thin layer chromatography kind of differs from paper chromatography in the sense that it also uses silica plate as a stationary phase, and it operates in the same like sort of principle. If we have greater solubility in the solvent, then it's going to mean greater affinity towards the mobile phase, so it's going to travel up the chromatograph. If it has greater affinity for the solid phase, it's going to be a little bit less in terms of travel distance. Next, we're going to have two-dimensional chromatography, and this was kind of like my favorite. The reason for that is because two-dimensional chromatography is kind of like this really creative way of utilizing all the properties of chromatography. We essentially turn the paper 98 degrees clockwise and use another solvent in order to fully see which all of the substances are involved in the mixture. So if, for say, one substance has like same R value as another substance in the same mixture, we're obviously not going to be able to like distinguish fully all of the substances that are involved in the mixture. However, if we flip the paper by 90 degrees clockwise and then use another solvent, because the solubility of the two substances that are in the same spot are going to have different like solubilities in the second solvent, this is going to lead to them being separated as well. So I think this is again a very, very clever way of being able to just really separate all of the substances.